Welcome back to the radio room. Been a little while since I've had a chance to make a video. Had a lot of stuff going on. Had a little bit of had to fix a few things in the radio room here. Last week had a severe thunderstorm with some tornadoes up north of town, and some rather large hail knocked out a window in the radio room. So on top of wanting to get a couple of videos going with some older equipment that I ran across, had to clean things up first. Just got a boarded up window in the radio room right now, but we'll see if we can't get that fixed in the future, but that doesn't affect the videos now. Got glass and grass and everything else cleaned up out here pretty much. Still be finding it, I'm sure, for the next year, but let's get back to looking at some interesting stuff as far as older equipment that I ran across. On the bench here, you might recognize this this audio frequency oscillator here. It's a HP204C, and if you remember, we did a video series a little ways back where the power supply wasn't producing the right power because it didn't have batteries in it, and it couldn't have a zero voltage reference for the positive and negative 13 volts. I ran across this one a couple of weeks ago, and it's got a little bit different battery system on it than the other one. This one was set up strictly to run off of batteries. When the batteries went down, you just had to change them. So I wanted to look at this one right here, mostly because one of the previous owners had made it so that they could plug in I'm guessing a DC power supply to right here. Just using I'm going to guess that's probably just an 1/8 inch headphone jack. And it says 24 to 28 volts DC only. So it looks like they've probably gotten rid of the batteries, and they could just plug it in right here. Well, I'm kind of curious, and I wanted to kind of make a video of this, opening this thing up and seeing how they wired this in. Do they have some sort of scheme in here that's providing the positive and the negative 13 volts? Or I'm guessing anywhere between 12 and maybe 14 volts DC, positive and negative. Or are they just feeding this strictly with up to 28 volts going to the positive side, and the other one, the 0 volts of positive DC going to the negative side? I'm not really sure. Do they have any connection to the ground connection? What we were calling the 0-point reference when we built the junk box power supply. So I hadn't opened this oscillator up. Still needs to be cleaned up some. But I thought I might take you along on opening this up and taking a look at what they got in here. Is it just straight wired in there for 28 volts, positive 28 volts, or did they come up with some sort of scheme in here to get the positive and the negative 12 to 14 volts? Is what I would suspect if they did that. So let me get some stuff set up here, get the cameras changed up a little bit, and we'll pop the top and the bottom and the back panel off of this. I'm hoping it still comes off. Like I said, I don't know how they wired this in. So let me get some things set up, and we'll get into this oscillator and take a look at what somebody else did. Maybe they came up with something really ingenious, and maybe even have a better solution to powering this oscillator than the junk box power supply does. Let's take a look. Alright, so let's grab a screwdriver and see if we can't find out how they did this. if I do remember correctly, we have to, I believe, take this bottom foot off. Which, if I remember correctly, wasn't the easiest thing in the world to do. Let's just do this one screw and see if this thing will pop out of here. If I have to take that off, and there's 2 more screws underneath there. I don't remember from the last one. Oh, no, we can just pop that off. And then, last time, this is the part that got really loud. So I'm going to do that gently. Alright. This one's a little different. Almost looks like I got to unscrew this back panel from the something's definitely holding it. This is definitely different. It's not as removable as the last ones. Although it does look like it's connected through to the definitely different than the other one. Actually, almost looks like you got to take the sides off. Maybe to get this back panel out. Unlike the other one where once you got this far, if I remember correctly, you just pulled the back off. Well, let's find out. Let's get this side off and see what it looks like underneath here. Might be those right there you got to take out in this case. Looking more promising. Now it's starting to slide off. Set the oscillator out of the way and we'll take a look at this back panel. You can see right here they do have the that's the connector for the headphone jack. Well, let's see. We need to probably get this board off of here and see what's behind there, because however they got it set up is behind that. These are just the screws that hold this bar on. They screw through to the back panel right here. They wouldn't be nearly as long sticking through there if the batteries were in here. So I'm glad there's not batteries. It looks like 5 screws. Let's find out how they did this. Okay, I'm going to have to unsolder this. It's going to take a moment for the soldering iron to warm up. I can peek behind here. Well, I can see a red wire and a black wire. Not really telling me how they got it wired in here, though. I'm betting. So this is supposed to be our 0 volt right there reference, and then the negative. Let's see. It's a very interesting design. Definitely had some battery leakage right there. Bit of corrosion in here. In just a moment, I need to get a little bit of water in my sponge, and then we'll unsolder right here and see if we can't get that board lifted off of there. So let me get some water on the sponge and let the soldering iron heat up, and we'll be right back. Alright, so we're back. Got the sponge nice and wet, and the soldering iron should be warmed up. We'll just clean it a little bit. And re-tin. And knock one of the cameras over. Sorry about that. Let's try this again. I'll get something to pull that out with. Just got to get this one wire with connecting the ground plane to the secondary ground on the back off of here. Right like that. Alright, that comes loose. So, how do they have this wired in here? So, it's going to here. It's, oh wow. So the center pin is our positive. It's going here, which is connecting to one end of the batteries. And the ground is connected to the other end of the battery. So they are not having a 0-volt reference. Let me, I did have a schematic pulled out for this particular. I can do this with the light. That's just totally washing out. So let me get a little less light on the subject. Yeah, that's a little easier to read. So, I do have B+, I do have B negative with the ground in the middle, which is basically just the same way we ran the other one. If you'll notice here, right here, we got battery 1, battery 2. These are our 4 batteries right in here. So we got battery 1, battery 2. So that would be battery 1, battery 2. Get some more light back on this a second. Battery 1, battery 2, because this is the positive. If we look on the back, that is running down to positive. So this right here, and where they've hooked this, is right here. Where they got their ground wire is hooked right here. So it's right here, the other end of the batteries. So they're running positive 24 to 28 volts here and negative here. Or actually it'd be just 0 volts right here, with no real way to split that voltage. Because see here, you can see how this makes a positive 13.5 volts, and then this would make negative 13.5 volts in relation to that ground, which there and there is connected together via all of this. I'm not sure y'all could see that while I was doing that, but here is supposed to be our negative. That's supposed to be our positive. So I'm guessing it worked. I'm guessing the oscillator oscillated, but I'm not really sure how they were getting the positive and negatives to get the Lane Bridge oscillator to work. So that's very interesting. So at least we know now. Unfortunately, don't have any way to power this at the moment. I might have to come up with something with 24 to 28 volts. So I can't test this. Guess this video is not exactly going to be totally showing you everything, but we at least know how this is wired up. Like I said, I'm going to guess it worked. I think it would work much in the same way that the original one, before we made the junk box power supply, would work, in the fact that we didn't have the 0 volt reference between the positive and the negatives, and it oscillated, and it seemed like it oscillated pretty well. It was hard to check all the alignment, mostly because the first alignment is to check for the voltages, the positive and the negative voltages. So obviously we wouldn't have that. In fact, if you remember, I believe I checked that in the beginning of one of those other videos with that other oscillator, which just happens to be sitting right here. And up above that, right here, is the junk box power supply. I've kind of rearranged the bench and the radio room a little bit. Got more test equipment over in this area now instead of being on to my right. Gets it a little closer. So yeah, that's where that is. I guess we'll put this thing back together. I'll probably clean it up a little bit and take a look at, see if I can figure out if I got anything that I can get 24 to 28 volts off of. I'll have to think about that one. Maybe there's something I can put together that we can get 24 to 28 volts DC with some fairly clean output. Not thinking of anything right at the moment, but maybe I can put something together at some point here pretty soon, and we'll figure out how well this thing worked. Maybe it works good, and we'll check it out. Other than that, maybe we'll come up with a different power supply for this. Maybe battery operated. Maybe we'll still leave it battery operated, but let's not use the mercury batteries. We'll probably use something else. Maybe an external box that'll just screw to the back here. We could probably use those screws right there that are sticking through to hold something. Maybe some 9-volt batteries or something. I don't know how long it'll last, but yeah, we'll come up with something. But I just wanted to make a little video and show y'all what I found here. I'm not a real big fan of the way this is being powered, mostly because of the way that the original setup does have the positive and 13 volts feeding it, and I'm not a big fan of running 28 volts into, I believe, capacitors that were only rated at 25. They might have been 16 volt capacitors even. I mean, this one's only a 15 volt DC. I'm not really sure if it's still in circuit now. It is. But there's no reference to here. So, wow. That could have been a problem. That could have had more than 15 volts across it, depending on how the circuitry comes back and if it was feeding anything to that. In fact, I don't know. Let me see. There shouldn't be any connection between the ground and here, is there? No. Oh, actually there is right there. So let me, let's see. Actually, it'd just be the body of it, wouldn't it? Well, the case and this is not connected. However, when this wire is connected, and if you were to happen to put a jumper between these, that makes the case hooked to the ground of the circuit between these two, which is what these two binding posts are for, so that you can, if you need to have the case of the oscillator at the same potential as your 0 volts of your power supply, whether it be the batteries or if you have the actual plug-in, I believe it's option 2, or no, the standard power supply, which is just merely the plug into the wall one, or if you have the one like the other one that we did that had the batteries and the plug into the wall that basically just charged the batteries. If you connect these two together, this 15 volt capacitor would have had anywhere between 24 and 28 volts across it. That's a good way to pop that cap and make a mess and probably spew guts all over the inside of the oscillator. So probably before we use this, we'll come up with a better scheme. That should be somewhere down the line. I don't know if that's going to be a project we're going to work on right now. There's a couple other pieces of equipment we're probably just going to take a look at. Open them up, see what they look like on the inside. And then probably figure out from there what order we want to maybe do a little bit of restoration, minor restoration, at least get them working, see if we can't get them working good. I do have this oscillator. I do have a capacitor and inductance, or an RLC bridge. It was an older way to determine the inductance or capacitance or resistance of a component. Before you had a meter that you could just hook up and it told you. In a digital display, it had a bridge in there where it balanced the currents between a known side of the bridge versus one set known value, and then you have your unknown in that bridge. And when things nulled out, in other words, there was no current flow in one direction or the other, you knew what value that was, and that was by a dial that you looked at, and it basically told you what your inductance was of an inductor, if you had an inductor in there, or a capacitor, the capacitance of it, or you could even use a resistor and find the resistance of a resistor, which you don't do that anymore. You just buy a meter. If you want to know the resistance, you put it in ohms and you measure it. Or you have a capacitor meter. Or they still make RLC, but they're meters. You just, okay, that's a 2 microhenry inductor, or that's a 200 picofarad capacitor, or 200 ohm resistor. You just put the pros on there and you're good to go. This one, you had to work at it a little bit, but before they had meters, that's what they had. So we'll put this back together and probably try to see if I can't get some more videos coming back out a little bit more often. Just been really busy with a lot of other stuff, trying to keep the world going around, so to speak. So we'll just resolder this. Get that connected back up there like it's supposed to be. And we'll put this together real quick. And next video, maybe we'll take a look at another piece of equipment that I ran into. I like some of the older stuff. Getting it working again. I'm trying to make sure everything's working right. It's always fun to get a piece of equipment that's, in most cases, a lot older than I am, and make it work and use it. Even on modern stuff, use an oscillator or a voltmeter, or an old oscilloscope or something that to measure or diagnose or repair equipment, whether it be from the same vintage. Well, that screw this does not want to go back in there. Or use something to diagnose and fix something that, when the people who built the test equipment had no idea the advancements in electronics, but it's still a good piece of equipment to test electronics, because despite all the changes in technology, the way we do things, you know, transistors and, you know, versus tubes, or newer types of capacitors, you know, that are in things. You know, it used to be a capacitor might be 4 inches tall and an inch in diameter, and you know, now you use a capacitor that's, you know, what, 3/4 of an inch tall and maybe a 1/2 inch around. Does the same exact thing. But it's nice to use some of this older equipment, bring it back. There's a lot of history on some of this stuff, and history that I'll never know about. Stories that that piece of equipment has gone through. Things it's seen. I mean, like this oscillator here. It was built probably in the, I want to say mid-70s, probably. I think that's when I found out the 204C was being manufactured. And they put mercury batteries in it, because that was the technology then. Well, and it probably oscillated and sent, you know, it was used for signaling, injecting audio frequency signals into many different pieces of equipment, whether it be radios or sound systems. And the batteries died, and maybe you can still get the batteries, I'm not sure, but somebody still needed to use it, and they came up with something else. I mean, just like we built the junk box power supply for the other 204C. You know, keep it going, still working, and still able to be used in the way it was meant to be used. Which I just find that very interesting. People, they overcome things and come up with ways to make it keep working. And apparently this still worked. It's not exactly the way I would have done it. I would have kept it a little more true to the voltages that the oscillator wanted, but apparently it worked. I think it was flirting with damaging the equipment. Some of the capacitors, the voltages probably might be a little high on the positive side of things, but you know, it probably still worked. And maybe it doesn't work. I don't know. Maybe they hooked everything up. You know, wired this in here, turned it on, and something in here blew up. I don't know. Just looking down in there, it's dusty. I don't see any exploded capacitors. But, yeah, maybe it worked. Maybe it didn't. Maybe we'll get something that we can put 24 to 28 volts into this and try it before we redesign it. Now, let's see if I can get this card to line up. Yep. Finish putting this back together. And we'll visit it sometime in the future. I'm really kind of thinking it'd be nice to have this one and the other one running. I want to build a little combining circuit. A little deal that I can combine 2 different frequencies off of these. I do have another, you know, signal generator, a modern one, that can put out 2 different frequencies at the same time. And I could combine them together. And the reason for that is being, you know, if I want to do 2-tone tests on a sideband rig, checking the modulation on a sideband radio or something, you know, and use the 2-tone. Take a look at how it's kind of, you know, working in the modulation envelope and whatnot. Somehow I think they missed a screw in the wrong place. Well, these were all the ones that were in here, so we'll put them back in here. We'll It would be cool to use, oh, what would that be, 50-year-old oscillators, combine their outputs to inject into a radio to do tests with. I mean, one or another, it seems like, nope. Got the right screws right here. We'll get this put back together. Set it on the to-do list, and we'll revisit it in another video in the future. See if we can't fire it up in the condition that it's in now. See how it works. Take a look at it on the oscilloscope. And if things aren't exactly the way we want them to be, well, maybe we'll come up with a way to have the proper voltages going into it. And still be able to use it the way it was intended, as a signal generator, a frequency generator for audio frequencies. Primarily, when this thing goes up to, what was it, 1.1 megahertz, so it's a little more than just a audio frequency generator. But it does have a 600 ohm output, which just happens to match most microphone inputs on a lot of radios. I'm not saying all of them. A lot of modern, and the last 30 years or so, they tend to have a lot of 600 ohm inputs for the microphones. And that might come in very conveniently. Just feed right in there. We don't have to worry about any losses. I haven't played with one of these things exactly to see just how low the output goes. I mean, obviously, I think this thing's will do 5 volts RMS on the output. Well, we're not going to put 5 volts RMS into a microphone. We probably wouldn't have a mic amp in the radio for very long afterwards. But that's the 204C I ran into. Brought it home. We'll take a look at that other equipment in some upcoming videos, even if it's just to pop the top and take a look inside, see what maybe we want to do with them, if there's anything that's obviously wrong with them. Maybe some capacitors need to be changed, maybe check some of the resistors and stuff, see what the tubes look like. I don't have a tube tester, so I'm not sure I'll be able to test them, but we can check voltages and stuff. Might give us an idea. Alright, well, thanks for stopping by the radio room and taking a look inside how this thing was powered. Pretty dirty. And if nothing else, maybe we'll see if this one isn't real good. Maybe it's got some parts that it can be a donor for the other one, and we can really bring up the other one. This one actually still has HP on it right here. I was always wondering what the two little holes in the front panel were for. Right there, it's the HP badge, so that answers that question. Alrighty, well, that's the HP204C that I ran into, brought home. We'll get this puppy running one way or the other, unless it's just totally dead on the inside, but I don't think it is. We just want to get it some voltages that it might like a little better. Thanks for stopping by the radio room. See you later.